we are back learning about writing functions, and I would expect you to be able to identify independent and dependent variables at the end of this video, to be able to write an equation in function notation, and to evaluate a function for a particular input value. All right, so an input of a function is the value of x. That's going to be my independent variable. My output, on the other hand, is the value of y, or my dependent variable. Remember, I had my function machine. My input, my x, was going to generate my x output, or y. So that thing that went in was my independent variable, and the thing that came out was my dependent variable. The value of the dependent variable, what came out, depended on what I put into the function machine. So I'm going to put together a little table that shows all the different things that we have done with our x. Our x is a input. Our x is, we know now, an independent variable. Our x is also, so these were our x values. Our x was also our domain. Values are our output. Once we put that independent variable in, we will get out a dependent variable. And those are our range values. Remember that these values are the value of the function at x. So y is the same as saying the value of the function at x. Okay, so this would be useful to have in your notes so you remember all the different ways that we have referred to the input and output values of a function. So we're going to first work on identifying independent and dependent variables. So I've got a situation where a painter has to determine how much paint to buy. So of course he's going to have to measure the room before deciding how much paint he's going to buy. So the question is, the amount of paint, if it depends on the measurement of the room, which one is my independent and which is my dependent variable? Well, the amount of paint depends on. So the amount of paint is my dependent variable. The measurement of the room is my independent variable. It is what it is, but how much paint I buy will change depending on how big that room is. So my dependent variable, or my y value, is my amount of paint. My independent variable, or x value, is my measurement of the room. All right, I've got another situation where I've got an independent and dependent variable. The height of a candle decreases d centimeters for every hour it burns. Well, the height depends on how many hours it burns. Okay, so which one is my dependent and which is my independent variable? Well, I can burn it for any number of hours that I choose, and that's what decides how high the candle will still be. So the independent variable, or time, how long I'm burning the candle, will determine my dependent variable, the height of the candle. Remember, we talked about the fact that time would almost always be on the x-axis. Remember, the x variable is also my independent variable. So this makes sense that time would be the independent variable. Got another situation where a veterinarian is weighing the animal so they can decide how much medicine to give the animal. Well, what depends on what? The amount of medication depends on how heavy the animal is. So what is my dependent and what is my independent variable? Well, the amount of medication is the dependent variable, and the weight of the animal would be my independent variable. As long as I can say to myself in a sentence like this, what depends on what, I can determine which one's dependent and which one is independent. Company charges rent for a jackhammer, $10 per hour. So I know that the cost is going to depend on how many hours I rent the jackhammer for. So what is my independent and what is my dependent variable? Think about this for a second. My dependent variable is going to be my cost, because the cost depends on how much time or number of hours. Probably, I assume they're renting it in hours. Oh, yes, of course. Never mind. Number of hours. Let's try that again. Caleb is buying pounds of apples at 99 cents per pound. Well, let's write our sentence. What is dependent on what? Well, the cost is going to be dependent on how many pounds I buy. So what is my dependent and independent variable? Go ahead and figure these out. Of course, my cost is the dependent variable, because the number of pounds I buy determines how much I am spending on my apples. So this time I'm going to identify the independent and dependent variables, but then I'm also going to write a rule and function notation for this situation. Fitness center charges a $100 initiation fee, and then they're going to charge me $40 per month. Well, I know then that my cost is going to depend on how many months I'm a member for. So determine what your dependent and independent variables are. Go ahead and pause and write those down. Okay, so now I know that the dependent variable is my cost, because it depends on how many months I am a member for. And let's go ahead and write out that function. So I've got a function that's determined by the number of months that I am a member. So the function based on the number of months is equal to, I've got $40 per month. And then, of course, I have that initial $100 fee that I have to pay for initiation. Okay? I also wanted you to be able to determine evaluate a function for a given input value. I've got a function g that is determined by my input t. And here my function rule is 1.5 t minus 5. And I want to know when my function has an input value of t, in the first case 6, what will that value be? What if I were to evaluate it? So I know my function g at some point, some input value, and we're going to go with 6 first. What does that equal? Well, I would plug in for my t my input value of 6. So g of 6 equals 1.5 times 6, or 9, minus 5. So g of 6 equals 4. When I have an input value of 6, my function is equal to 4 at that point. One more, when I have what is the value of the function g at the point -2, so my input value of -2 will give me 1.5 times -2 minus 5, or g of -2 equals -8. All right, trying this again. For my real world example, I've got a space heater that I'm able to set to just whole number values. Of course, I can have it off at 0, or I can set it to 1, 2, or 3. And each time I increase the number on the dial, it will increase my wattage usage by 500 times. I'm going to write a function rule to describe the number of watts. Then I'm going to find a reasonable domain and range for this function. Well, for every input value, or the level that I'm setting it at, I'm going to multiply by 500 to get me my output value, my y. Okay, so what would be a reasonable domain? If you think you know, pause the slide and fill it out, please. My domain, of course, could be 0 because I could have an input value of 0, doesn't have to be turned on. And remember, my only settings are whole numbers, so 1, 2, or 3 would be my only other values for the domain. If those are my domain values, then my range values would be off. I'm not using any wattage. My output, if I move it to 1, would be 500 because every time I increase it goes up by 500, 1,000, and 1,500. So let's think about what that graph would look like. Here I'm going to have my, I don't know, my knob level, I guess. And here I'm going to have my wattage because my output is my wattage. So if you were to graph those points, what kind of graph would I have? I'm going to have a discrete graph because those values, the knob levels, can only go by whole numbers. So I'm going to have a series of dots representing the wattage output. So I wanted to go over again really quickly the writing an equation from X and Y values because this really goes back to when you did sequences last year. And so this is much easier than you think it is. And we're actually going to be getting to this again very soon when we start talking about slope and rate of change. But what I want you to be able to realize is that every time I put in an X value, it's increasing by 1 because I'm determining that I want to increase it by 1. What is happening to my Y value? Well, my Y value, every time I increase my X by 1, my output decreases by 2. See how that decreases by 2? This one also decreases by 2, and it decreases by 2. Well, every single time I increase my X by 1, my Y decreases by 2. So let's go ahead and write that. So for every time I change my X, every time I'm increasing it by 1, what's happening to my Y? It decreases by 2. So increase this by 1, it decreases by 2. So let's just check this to make sure this worked. F of X equals negative 2X. So my F of 1 would be negative 2. Negative 2 times 1, or negative 2. So for a value of 2, F of 2, I would have negative 2 times 2, or negative 4. If I have an input value of 3, I'm going to have negative 2 times 3, or negative 6. So this exactly matches my chart. So that's perfect. I am very happy. Just slide. Okay, so notice what happens when I change my value of X. What is happening to my Y? Well, if I put in a 1, I get out a negative 1. If I increase that 1, I get out a 0. So I have increased my output value by 1 every time I increase my input value by 1. So increasing my input value by 1 led me to increase my output value by 1. So 1x. So if I were to plug that in, so f of 1 should then equal 1 times 1, or 1. F of 2 should equal 1 times my value of x of 2, which would be 2. But this isn't matching what I wanted here in my table. It is increasing by 1 every time, but I needed it to be at negative 1. What would I need to do to get that 1 to be a negative 1? Well, notice if I subtract 2 from that value, I get my negative 1. If I subtract 2 from my value, I get 0. So my rule then is every time I increase my x by 1, so I'm increasing my x by 1, but then subtracting by 2, I get the value in this table. So f of x equals x minus 2. And like I said, we'll go over this more when we get to rate of change and slope, but for purposes of the quiz on Wednesday, I want to make sure that you know how to write these. We will be going over these, so please have them written down on a separate piece of paper or somewhere in your notebook that we can check them on Monday. Enjoy your weekend. See you on Monday.